Hello, Eric. Given it's the two of us in the course, and I've went through all the material for all of the modules and deliverables, thought I'd circle back and talk a little bit about deliverable 5. Then most likely going forward, I'll just shift over to more of an office hours sort of approach where I'll be in a meeting at the scheduled time. If you have any questions, stop by. Or if you have something you'd like to send me an email or a message, feel free to do so. So what I thought I'd do here is kind of walk through how I would do deliverable 5. Obviously, there's some of this that I'm not going to do because, well, it would take a while, such as write a paper that talks about what Spark is and how it works and why it's better than MapReduce and so on. But I can do this bit about the queries related to the cellular data. So the process would start off by downloading it, right? So we need to download the data as a CSV, and it comes down. Once it's down, I would navigate into that folder, which is on a different monitor right now. Apologies for that, but there's some other stuff in my downloads probably wouldn't want to share. So once I had downloaded the file, I would drag it over and drop it. So I'm literally dragging the file cellular service-areas.csv and dropping it on this box inside of Databricks Community Edition. And then it's basically uploading the file. Once it's finished, it asks me if I want to create a notebook or create the table with a UI. So we'll do it with a notebook because it's a little more intuitive, a little more descriptive of what's going on. The file that I uploaded was placed into this location. Looks like I've probably done this a couple times, right? Because it was already there. It knows that it's a CSV because of the extension. Then we can tell it that we do want to infer the schema, which basically means it's going to look at everything past the header row, which we also know there's a header row in this file. And it will essentially try to load that file, take a look at the contents of the various columns based after it did the split off of the comma, and figure out what it is. And basically this code is what it wrote for us to do that. So it reads the file, setting some options, and using the location, and then basically displays it. So I'll go ahead and kick this off. In order for this to work, we have to start a cluster, right? So Databricks uses clusters, Spark clusters that are managed by the environment. It actually right now is provisioning a cluster, going out and creating one. We can take a look at that if we're so inclined by going up here and clicking on this little pop-out arrow on the compute, and it'll actually show us the cluster as it's being created. As I've talked about in the past, we can do this ourselves if we were so inclined, but it usually goes better to let it do it. The cluster that's being created is not necessarily the most powerful thing. It's a single user or single computer running both the workers and the driver. So it's a single box cluster. It has a little bit over 15 gigs of memory, has a couple cores in it, and it's a relatively inexpensive thing to run, one Databricks unit per hour. So the 15 gigs is basically what you get for free, and it will turn down after a period of being idle for 2 hours. So you can use it for 2 hours, or if you keep using it every, as long as you do something more frequently than every 2 hours, it's up and running. The UI here is, some of this stuff isn't available just yet because it's in the process of being provisioned, but this would be the place, like libraries is where you go in if you actually want to do something like install a particular library, something perhaps in PyPy. Some things are already in the runtime for you. You don't necessarily have to install them, but there's some things that you would need to install yourself. There's other things here like the event log where it says that, hey, somebody asked, in particular me, to create a cluster, so it started it at 1 minute and 30 seconds after the hour. The Spark UI won't be available until things come up, nor will the driver logs. And the metrics, there's no real history here because it's a brand new environment, and there's also nothing on the master, the Spark cluster UI for the master because the driver node and all the nodes, none of them, given that there's just one, are up and running just yet. So it's in the process of creating it, and the status says that it is pending and attempting to go out and essentially provision the machine where this is going to run. Switching back over to the workspace, or I can just go back to the home page because it should be there. And I just double clicked on the wrong thing. So because I've got it so much larger, we can go back and look at the workspace and look at my most recent. And that's not it. And it's part of this is I'm kind of waiting for that to come up and finish running. So it'd be this one, 11.3. And so it would probably make sense if you were doing this for real that you'd probably take this and maybe change the name. And this is a Python notebook. So that you can, the default language inside of a cell is going to be Python. It is still in the process of creating it. So basically, we've talked about what this is. We're doing spark.read, and we're saying what type of file it is. In this case, it's a CSV. And we're inferring the schema because it's true. And we're also saying that the first row is a header and that the separator is a comma, and that the place to get it from is this file location where we uploaded it to. What you get back from this spark.read is a data frame. Data frames are kind of like Pandas data frames, except they're for Spark. They're based on the RDD, the Resilient Distributed Data Set, or data frame construct that allows for failure recovery. If for some reason your cluster has a node that goes down, it can pick back up from a point where that particular node should have been at, and some other node can pick it up and do it for you. The thing with a data frame is that you kind of have to use code to interact with it. In particular, we'd have to use Python code because it's created in a Python cell. If we want to do something like take a look at it from a different environment, we might want to create a temporary table. The temporary table would allow us then to switch over to a different language, such as SQL, and then essentially run a query against it, saying something like, and I'll go ahead and just say view at the end so that we know what it is. So then we can select from that view and do operations that perhaps are a little easier to do in SQL over writing it in Python. Then if we want to take that and actually create a real persistent table that's going to exist beyond a particular instance of the server running, so after for as long as we are in this workspace, we can call save as table, and in this case it's saving it as a Parquet format. So it's going to create a Parquet file or set of Parquet files that are going to make it look like a table in the sense of like a Hive table or a database table. And this will let us go in and actually do work against it. So there was my notebook that I had misplaced. So taking a quick look back, sometimes there's a little bit of a UI glitch here where the cluster will actually be up and running, and it may not look like it is just yet in the one UI. Sometimes it does take a while to spin this up. It is running inside of a AWS environment. Not that that's why it's slow, but that's one of the kind of characteristics of this. Another thing that you can do, if as an advanced sort of topic, is you can go through and start changing things like the Spark configuration. So inside of Spark, you have the ability to have essentially something similar to an init file or a config file. And it enables you to set things that may or may not always be what you want to do. So we can do things like turn on Delta preview to be true. You can also access this cluster as an ODBC or JDBC endpoint, which means that you could do something like have an application that's written that connects to it and then executes some SQL statements to do whatever operations that are necessary. The key thing you have to do here, though, is you do have to go and create a personal access token. While this is spinning up, I'll go ahead and show you how we do that if for some reason you wanted to do it. So you go into, I'm pretty sure it is, and I always look in the wrong spot. It's user settings, although I did not see it, and it could be a community edition restriction, and it kind of looks like it is. So the SQL endpoints probably are not available inside of the Community Edition, although it's interesting they didn't hide it from the one location. So basically it's a token like any other token that you see. I'm waiting on something to come up. Yeah, so it's not available to you inside of this. But basically, what it is in the real version of Databricks is it allows you to connect to it as an ODBC connection, and you just have to supply a token, which is something that's issued. It's a magic string. You can set an expiration on that magic string, and then at some point you can also invalidate it as well if you were so inclined. So checking back on our cluster that's still not quite up. It is taking a few minutes, unfortunately, to come up. So I'll go ahead and, while it's doing that thing, kind of start with what I would do to address this project in general. I would probably go and create myself a notebook, and all I did here was do something like create notebook, and I would select SQL as my default language because we kind of know that might be the easiest way to do some of these operations. I would also probably take this query and I might even do something like this, of basically just copying over the first bit that has something to do with this assignment and go into the first cell, say that I want it to be markdown by adding a %MD, and then paste it in and then turn this into true markdown. And what I'm doing here is really nothing more than the pound sign is equivalent to a heading level 1. You typically want a space between it so that it doesn't try to wrap stuff. And then at the end of this, if it went well, it looks really pretty nice, right? So here we're using the provided cellular data set, and we're creating a Scala query, and I will certainly accept SQL because language inside of Spark is kind of irrelevant. And if it matters, you're probably not doing it right, is the short answer, because what happens with anything, be it Scala, Python, or SQL, or R, is that it takes it, essentially compiles it or parses it into something that can be represented using that DAG, that directed acyclic graph, and then uses an optimizer to figure out the best way to do that, right? So really, truly, language should not matter. Since we're going to create a permanent table over here, and we can do it now, I'll go ahead and get this started by doing what you normally do, and just take the first 10. So let's go ahead and create our table now that the cluster is up and running. We should be able to step through this, and there we go. Did it work? Yeah, it worked. So it is running. It did finish. It showed me the first 1,000. Notice that there is a heading, and also you can, we'll do it after we create the table. So first we can create a temporary view. We can select from that temporary view, and if I don't introduce noisy characters, it'll work. So there was an extra pipe in there or something. So we can see it's the same basic concept as doing the display of the data frame, right, which is what we're doing here, but the difference is we're doing it here with a select statement against that temporary view we created. So it's a whole lot easier, right? And lots of people know SQL, and at the point that performance is essentially the same, why not use the tool that you're most familiar with? So at this point, we're going to go ahead and create that permanent table. And I pasted in the wrong thing. And we're going to call it cellular service areas. And at this point, it's actually taking that data frame that's in memory, that's being represented at the moment as a temporary view, as well, but also just taking that data frame and basically saying I want to save this off as something else, in particular a table. So now that that's done, we can go over here, and inside of this, it's not smart enough to connect to the right cluster. Inside of this cell, we can run just a straight up SQL command, right? And it's to give me the first 10 out of it. So in particular, what we want to find is, oops, and I am just having a real rough time typing today. The top 3 licenses and licensees, and how many each holds, and so to turn that into something a little easier to see. So the top 3 licensees, okay, and I would assume that's the top 3 based upon the objects that they own. So it sounds like a group by to me, right? So we're going to go ahead and just make it a little prettier than it could be. And I'll go ahead and make that a heading level 1. If I hit the right key. Also note that you can pop out this this little navigator over here, and then it lets you quickly go to each one of the sections as you've defined them. So in this case, I'm going to reuse the first bit of this because we kind of need the select part, right? So we're going to select count, and you can do count 0 or count star or count 1. It really doesn't matter. As count, comma, we'll say licensee. And then we're going to group by licensee. And then we're going to order by count. And with any luck, that'll work. And so what that's doing is putting them, it's basically how many licenses each one holds. And we get that. And we probably want that to be descending, right? Because you probably want the biggest one first. And you want the top 3. And it should be limit 3. And there we are. So that's pretty much it. And you also know how many licenses each one owns. So pretty straightforward and pretty quick, in spite of the cluster taking a while to come up. You could also, with a little bit of effort, so you might want to just repeat that, just so we can play with the results. And basically do something like a bar graph, right? And so that's how pretty easy it is to basically plot something in a certain way. So we got count on one dimension and the number and the licensee by which one, and maybe that's not what you want. So maybe there's a pie might be a better representation so that you can see who has most of the counts, right? So again, this is probably not going to put something like Tableau out of business, but yeah, we want to do some. But it is something that lets you see pretty quickly kind of what it looks like and what it means. And in this particular data set, it's pretty straightforward. And another thing that a person, I mean, if you start looking at, well, what does it mean whenever you say the top, right? Because it could be, if you're looking at area, and this is one of those games that cellular companies play, as they talk about the largest network. Okay, what does that mean? Well, it could mean geography, right? So we could say take this same basic query and modify it slightly, because this is one of the key things, is I'm sure you know, it's important to figure out what the answer looks like and what is the actual thing that you're meant to be doing the exploration. So this gets a little more, so this is actually doing it by So we wouldn't want to do count. That's what I'm doing wrong here. So we would want to do sum of area, shape area, as area by licensee, and we would want to group by order by area descending. So, and probably take that limit off just for now. And so if you consider it from the sum of the areas, it looks a little different, right? You would, and it's because of the fraction on that one, to where it's definitely, is that, let's take a quick look at something here, because that seems off, right? This doesn't seem to be in numeric order. It may be, oh, it is. It's just that the numbers were in the wrong order before. So we were looking at the smallest. So you can see here it does make some sense, right? Because the ones that have the most of essentially licensees, right? So the particular area, the one that has the most of those also has the most area, which is what you would kind of hope, although it could be different, right? With that, I've kind of done most of, I believe, the analytics for this assignment, right? Let's take a quick look again, with the exception of this bit here of talking about how Spark works, right? So we did do and if you wanted to do the query, it wouldn't be all that different, right? So we basically are doing a group by. And then an order by. And so I'm quickly Googling because I always forget the syntax. I use Scala some, but I find myself pretty much, if it's something that's essentially analytic work, doing it in SQL instead. So, and I'm pretty sure I know what it is, but I don't want to type it wrong to start. Just for fun, we'll see how this goes. We know the name of the table. So you'd start off, you have to say Scala because this is a SQL notebook, but we can do this inside of here. And we basically want to say val some data frame equals spark.sql and give it... And you could, if you wanted to go to the letter of the assignment, paste this statement or this statement into this construct, and then just do a display data frame. And you've technically done what it said. You've written a Scala assignment or a Scala statement that does it. It just happens to be that Scala statement is evaluating SQL. So not exactly what's meant to be done, but what I'm doing here is I'm constructing a data frame from this select statement. And it's, again, another way of kind of crossing boundaries of processes. I could also have read directly from this location out here where we saved the CSV, and I could have done basically the same syntax with a val in front of the data frame, and val just as a way of declaring a variable, and it been basically the same thing. I do this sort of construct a fair amount. There's also another way of getting a data frame from a table, essentially. So given we now have a data frame in memory, again, we'll go ahead and just keep it in separate cells to make it a little cleaner. The next bit would be to, I called it df, we'll write it and then come back to a df dot group by license E dot count. And we'll do this just to try it out and see if we're getting down the right path. And it is grouping it. It's not doing any kind of ordering, right? So then and give me 1 sec while I look up the next bit. And I'm pretty sure it's now order by. Well, we'll try this and see how it goes. And let's see how that goes. And it's in the wrong order, but it is in order, right? So we are at the top here. Go to the very bottom. It is in the right order, and I'll run it again because one of the things with this display, this control down here, is that it'll actually let you sort things. So I wanted to run it again and make sure it really is in the right order. Just the next thing would be to do a descending, which is, it's a little different in each of the languages, so you sometimes have to come back and add this to, I think, here. Nope, that's not it. Maybe it's here. Nope. It's always a little different. This is the one area where Scala is a little different than in Python. You say order by and then comma. It's a parameter where you throw it into. You basically say ascending equals false to make it descending, right? So it's the and it may be what it wants is, oh yeah, it is backwards. Dot DSC, is that it? Oh. I'm not seeing my Scala examples, which is part of my challenge, and part of that is, I think, I think Google is smart enough to know what I normally do, which is search for it in. Okay, yeah, it always seems a little weird to me, but I think it's. More paren. All right. I'd have to be more prepared than I am to do this, apparently. Group by dot count. So it's saying to do this. $sign dot DSC. There we go. And then probably dot limit 5, or in this case 3. So kind of muddled through it, but you can see it's very similar. And what's happening underneath the covers, if we open this thing up, it's doing the same stuff. Because there's the environment is smart enough to go through. I'm not sure it's going to let me do the actual real poking around in here to see. Let's take a look and see if it does. Running slow, so probably not. So it basically takes that SQL statement, turns it into something that the Spark environment knows how to use, and it does the same thing with the Scala in statements. So you're not actually running that Scala. You're defining what you want to happen with the Scala, hence the kind of functional / descriptive nature of Spark, right? And then once you've done that, then you kind of can let the environment, be it whatever, do that work for you. A key concept also is that whenever Spark was originally written, it was written in Scala. So there was some that would argue, well, it's going to be better if you write your stuff in Scala. The reality is that's not exactly the case, because there are now versions of it's not letting me see the Spark UI in Community Edition either, so it's kind of interesting. So there are some definite limitations on some of it. Databricks has actually rewritten the Spark engine in Python so that it's doing its operations inside of Python in C++, so they call it Photon. And because of that, the motivation to write something in Scala is even less relevant, right? Because you're basically, at the end of it all, it's not like it's really running in Scala anyway, so there's no way you could argue that it's going to be faster or more efficient. So that's pretty much poking around doing the kind of the coding part of Deliverable 5. Not the hardest thing you'll ever write, and so it definitely is, but it is kind of something that you do a fair amount inside of these sort of environments. So with that, I'm going to go ahead and wrap things up. As always, if you have any questions, get stuck on something, want me to talk more about something, let me know. I'll be glad to record something and share it. Otherwise, I'm going to basically shift over to office hours. So if you need me, stop by. And if you need me to shift the hours to something that works a little better for you, if you're actually struggling with anything, let me know. I'll be glad to help out. So stay safe, and we'll talk again soon.